Selection sort can be implemented in two ways. One is finding largest item each time, then swap with the ending position, swap it to the end. Or you're gonna find the smallest item and swap to the first. All we're going to do is finding largest items and swap it to the end, but you have to know both way. Anyway, in both way, we're going to need n-1 phrase. So n-1 iterations will be needed. So when we have 1, 2, 3, 4, 5, 6, 7, 8 items, we are going to have a pass 1 through 7. So n-1 times we are going to have. I'm going to put the index number first. So because we are going to index to swap, we're going to use the index for swap. First, we are going to look at the old data, then find the biggest one, max. Find the max position. Max position is index 5. Then we're going to swap with the current end. The current end is index 7, so you're going to swap two values. Then you are going to put everything else. What this means, test 1 is done, and when test 1 is done, it guarantees last position, the end position is sorted. Because biggest value goes to the end, so it is sorted for the index 7. That means next time you are not going to visit index 7 anymore. So you are going to compare only index 0 through 6 and find the next max. The next max is again index 5. Then next end is index 6 now. This is now end position. So compare max index and end position, and swap max index and end position. Then after you swap, the rest of them I just fill out. Then it guarantees now index 6 is sorted, so do not touch at all. And keep doing this one. So I'm going to find the next max value, then next end, then swap them, and the rest of them I copy. Now index 5 is done. Don't touch anymore. Next max is index 2. Max index is index 2. Then end index is index 4. While you're doing that, you are not going to use a max value at all. You are going to just use index. Then index 4 is now done. Now max index is index 0. Next end index is 1. So swap. And the rest of them I copy. Oh, this is already sorted, so can I stop? Actually, computer does not know if it's end or not, so you need to keep doing. So now I'm going to find max index and end index are the same. So only one thing you can add to your sorting code. If it's the same position, I don't need to swap. That means you are going to skip one BIGO, one process. Or you can just anyway swap because swap does not take a long. Swap method is just a BIGO one. You can just anyway do it too. So I'll just anyway do. So 2 will be swapped by itself. Index 2 will swap by itself. So it swapped then and index 2 is now fixed. So you do not touch at all. Then when I have the same values, what will be my max index? We usually set up the very first one as max because until we do not find the bigger value, we do not change the max index. So in this case, I'm going to have a max index as 0, and end index is 1, so actually swap them, even though they have the same value. Then index 1 is done. When I have only one item, we say it's sorted because there's only one thing, so you don't have to do the last one. Now there's exercises about the selection sort if you understood correctly or not. So number 1, suppose you are finding the largest and swapping to the end. What does this array look like after 3 passes? So I have to swap 3 times. The selection sort is like a 4 n minus 1 times. What you do is find the max and swap. We are going to do those things. Let's see. First, I need to find the max, then swap with the last. Now, pass 1 is done. Now I'm going to change the color. So this one is done, so I'm not going to touch this one at all. So 8 is the final value here. Then I'm going to find the max, swap with the current to last. Now, second pass is done. And I know 7 is done, so put down here. Now next, find the max, that is 6, and swap with the last from the end, that is, it's going to swap by 12, so I'm going to put 6 down. What is my current? The rest of them is 4, 3, 5, 3, 1. Not just the last 3, the other values order also changes while you are swapping. So you have to do all 3 passes manually when you solve this kind of question. So number 2, how about now, different way? Find the smallest and swapping. That means it's the same thing like in the for loop or n minus 1 times. We're going to now find the mean, then swap. Oh, so this is the same. So I'm going to do that. Swapping to the front. So find the mean. So I found the mean, then swap with front to front. So swap them. And it guarantees the first one is now fixed. So when you find the next mean, you're going to from index 1 to the end to find the mean value. I'm going to change the color to green, then I'm going to find the mean. Actually, I can find the mean as the very first value. Then this one is also the current to front. So swap by itself. And this is fixed, so don't touch it anymore. Then next time, find the mean and current to front. So swap them. So 3 and 7 is swapped. Then index 2 is now fixed, so I can just copy down. And the rest of them, I'm going to copy 7, 4, 8, 5, 6. After 3 passes. After 3 passes, you can see first 3 items are guaranteed to be sorted. Then also the previous question, last 3 items were guaranteed as sorted in order. Now let's see the back page. So number 3, let's think about the BIGO efficiency for the selection sort. First time you are going to compare. First, when I find the max position, I'm going to start next position as index 0. Then compare with 6. So it is 1. Then max position now becomes index 1. Then compare with next one, that is index 2. So 2 second compare. Then compare with index 3, that is value 7. That was another compare. And now 7 is bigger, so max position is pointing 7. Then keep comparing to the right direction. So compare with index 4 and compare with index 1. So there are total 5 comparisons. Then show the whole list. Now, after I compare until the end, now what will happen to this data is 7 and 1 will be swapped. Then next time, I'm going to compare only among 3, 6, 2, 1, 2. So up to here, not touching 7. Now I'm going to try again. Now I'm going to do the second pass comparison to find the max. Starts from the index 0 as a max position. Then compare with index 1. So there was one comparison. Then, because 6 is bigger now, max pose is pointing 6. Then compare with the next index. Then compare with next index. Then compare with last index. So there are total 4 comparisons happened to find the max position. And in the selection sort, max pose and current end will swap. And second last index is now done. So next round, we will have 3, 2, 2, 1 as the value. Then 6 and 7 we do not touch. And if I compare, max position is pointing index 0, and compare with index 1, compare with index 2, compare with index 3. 3 times comparison. Then swap will happen. Now next time I have 1, 2, 2 only, and 3, 6, 7 are already sorted. Next position starts at 0, index 0, then compare with the index 1, compare with the index 2. Then next time, I have only 1, 2. Actually, there was a swap happened because max position was index 1. Then this time I'm going to use green color. Max position starts from index 0 and compare with the index 1. There was one comparison. And max position will point to index 1. Then it will swap by itself. So finally, the whole is sorted. So total comparison is 5, 4, 3, 2, 1. So total 15 comparisons. We can also use arithmetic series formula. When I have n items, n items starting from the n-1, n-2. So when I had the 6 items, I started from 5 to 1, right? So that means I can reorder this one as 1 plus 2 plus up to n-1. So first item plus the second item times the total how many items over 2. So there are total n-1 items. So 1 plus n-1 is n. And total how many items over 2 is n-1 over 2. So that is also 15. Therefore, here is a 6-item array already in sorted order. How many comparisons are made? Still 15. Here is a reverse order, still 15. So, this one is saying to you, very consistent. Consistent. So selection sort is very, very, very consistent. Every time for the best case, the worst case, average case, always 15. So we go n square. Why this is n square? Look at n times n-1 over 2. If I simplify this one, n squared over 2 minus n over 2. This is a quadratic function. N squared. So I can rewrite this one as 1/2 n squared minus 1/2, and we do not care about the coefficient. We do not care about low degree. So B efficiency is n squared.